Good afternoon, all of you. So now today we are going to start our unit number 2, computer graphics unit number 2. So in unit number 1, we have covered the basic primitives of the graphics. What are the requirements of the graphics that need to run any graphics program on your computer system. Suppose you are implementing in Windows, so that time you need to install, that is BGI graphics interface. Okay. Borderline graphics interface, okay, that you have to use in Windows DOS box. Suppose you are implementing the program in Ubuntu, so that time you have to use libgraph. But some student having a problem at their end, they have not properly implement the program on libgraph, so that we are practicing on graphics.h, that is in a graphics. So in unit 1, what are the points you have completed? First of all, the line algorithm you have completed. Okay. Then the line algorithm, DDA, Bresson aims, and midpoint. And again, you have completed that circle algorithm. Okay. The circle algorithm, again having a DDA, Bresson aims, midpoint. Again, some point you have completed, that is the introduction to the OpenGL. OpenGL stands for Open Graphics Library. So that's the program. Again, we are executing on where, that's the Windows. That I will explain you how we are going to implement that program. Now then come for our unit number 2. So what are the contents of the unit number 2 that we are going to learn? So by using this line, that you can draw the polygon, means is the SPP syllabus content of unit number 2, polygon, introduction to the polygon, types of the polygon, having convex and concave polygon and complex. States the polygon whether that is any point or any line inside the polygon or outside the polygon, that is the inside test. So any closed figure, that is nothing but the polygon, okay, that I am going to draw you and then say. So polygon filling, so you have to fill inside area of the polygon by using these 3 algorithms. So that is the flood fill, fill fill, and the scanline fill. Again, windowing and clipping, means clipping means that you have to erase the part. The viewing transformation, 2D clipping. Viewing, that's means you have to view this transform in the window, so that is called as the viewing. Cohen-Sutherland algorithm for line clipping, okay. Sutherland-Hodgman polygon clipping algorithm, and Wheeler-Atherton polygon clipping algorithm. So these are the points that we are going to cover. Now in today's lecture, what are the points we are going to cover? So in today's lecture, we have to look for what is a polygon, okay, and then polygon types, okay, polygon reading, read the polygon in the store in 2-dimensional array, inside outside test of the polygon, that is even odd method or winding number method, and filling the polygon. Once you draw the polygon, that you have to fill the polygon inside area by using seed fill algorithm, edge fill algorithm, or maybe that is another name, boundary fill algorithm, flood fill algorithm, and scanline fill algorithm. Now just I have to share one paintbrush screen. So what is meant by the polygon? So basic polygon is a triangle. Suppose this is my basic polygon. So what is this? Is the closed figure. The polygon having a closed figure with a minimum number, okay, of the sides 3. So suppose I have considered this is my polygon is having a 3 number of the sides. Again, this is a simple paintbrush I am using. So now suppose I have to consider the another polygon is next is the your square. This is another one of the polygon. This is also one of the closed figure. So these are all the closed figure, okay, that I am drawing over here. So that the all closed figure. Suppose the triangle again I have considered the this type. This is also one of the closed figure. Okay. Then come the sides. This is also one of the closed figure. So these are all the polygon. Okay. Now another type. See, suppose I am going to put this another type. Means what are they have? Put these 2 types, convex and concave. Suppose, see, so any closed figure, so that's come to the definition, any closed figure with minimum number of 3 edges is called as a polygon. A polygon line is a chain of connected a line segment. It is specified by given the vertices. Suppose the P1, P2, P3. So nodes may be the coordinates P0, P1, P2. These are the coordinates. And the first vertex is called as the initial or starting point of the polygon, and then last vertex is called as the terminal point or the termination point or the final point of that polygon. So that's, I have already drawn. This is my convex polygon, this is my concave polygon. But how that is you are going to differentiate? See, the above three figure that I have drawn, 3-4 figure. So this is the convex and this is the concave. But why there is the difference in between convex and concave? So these are the figures I have drawn. Now another figure I am going to draw like this. This again one of the figure. This again you can say one of the figure like this. You can draw. This again one of the closed figure. Correct. Now see. So why this is the convex? Suppose I am going to consider any 2 points. Suppose I am going to consider any 2 points. Suppose that is the my 2 point in the blue color. Okay, this is my first point, and this is my second point. Okay, suppose I am going to consider this is my point 1, and this is my point 2. So these are the 2 points. Okay, so these 2 points, and these are the inside point of the polygon, and I am supposed going to draw the line from my that point to this end point, and this complete line inside the polygon. This complete line inside the polygon means what? That polygon is the convex polygon. That polygon is nothing but the convex polygon. So that way we consider any 2 points over here. Suppose this is my first point, and this is another point, and then I am going to draw the complete line. So this complete line inside the polygon. But here suppose I have considered this point, okay, and another point over here, and then I am going to draw the line. So this some part of the line is outside the polygon. See, this is the some part of the line is outside the polygon. Means what? This is the concave polygon. This is nothing but the concave polygon. So another example again, I am going to draw like this. So this is one of the example specific I have to draw, so that you can understood. So these are the 2 points I have to consider. Suppose my point is this, and then I'm going to draw the line. So this is my first point, okay, over here, and second point over here, and then I am going to draw the complete line. See, the some part of the line is outside the polygon. That's why it's a concave polygon. So that's why the polygon having to differentiate. So that is the convex and concave. Now come for that is for concave and convex polygon. Now how can reading and entering the polygon coordinates? Now once you have learned what is meant by polygon, and then you have to read by using a program. So how can read? So we can store the polygon into the display file by using the algorithm. Okay. The information required to specify the polygon is the number of the sides. Means suppose you have need to draw the polygon, so you have to say the user, you have to enter first how many number of the sides you want, or number of vertices. Another is what? The number of vertices. And then the coordinates you have to read, and that coordinate you have to store in a points. I mean that is the pixel coordinates. Suppose so P0 point they have entered, so P0 having x1, P0 x0 y0, P1 x1 y1, P2 x2 y2. So these are all coordinates that you have to read and store. We can use the array. So that you have to store in the array to pass the coordinates in the vertices of the polygon entering. How it is possible? See. So this is one polygon I have put over here. So which type of this polygon? It's a convex polygon. Because of any point you have to consider that point, the entire point is inside the polygon. The entire line inside the polygon. That's why it's a convex. Now this polygon having starting coordinates A 11, B 32, C 54, D 37. These are my coordinates. So this is the output point. OP I have said. Output point is what? 1, 2, 3, 4. Okay, actually this is the 4. But what I am taking 5. Why? See. So this is my XY. First point I am going to draw 1, 1. Now 1 to 2 I have to draw 3, 2. Okay, 3, 2 I have draw this first. Then 3, 2 to 5, 4. 5, 4 I have draw. then 5 4 to 3 7. Okay, 3 7 I have to draw, and again I am going to draw this A. So that's why fifth point. A is what? 1 1. So fifth point and the first point means first point and the last point having a same coordinate system. That's why you can draw a closed figure. Suppose I have to say over here, this is my one of the triangle I am going to consider. Okay. This is the one of the triangle, and that's point. Suppose I have to start from this. So this is my starting point. I have considered over here P. Okay, P1. Suppose x1 comma y1. This is my first point I have to draw. This is my second point. So what is my second point? P2. P2 is what? X2 comma y2. Okay. Now P3. Here I have considered the P3. P3 is what? X3 comma y3. Now when I am going to draw the line, okay, suppose I am going to draw any kind of the line, so that time what you can do, suppose I need to draw any line, so line having a point, suppose see, so P1 to P2. Okay, suppose the first point is what? P1 to P2. This is my first line that I draw, P1 to P2. Second line I have to draw P2 to P3. Second line I have to draw P2 to P3. Now third line I have to draw again by using P3 to P1. So P3 to P1. So that is going to complete my polygon drawing. So this P1 point I have to draw two times. This P1 point I have to draw two times. So that's why here you can say this P1 in P1 dash. So P1 dash, you can say this is my point P1 dash. So X1 dash comma Y1 dash. So this point P1 you can draw it two times. So that's why I have entered two times. So this is actually 3 point. But when you are going to draw this point in a computer programming, in a program, so that time this P1 dash, X1 dash and Y1 dash is considered as next. So what you can say here, X1 is equal to X1 dash and Y1 is equal to Y1 dash. Means this point you have to draw two times. So how can I enter in the program? So come for the programming. So read the number of vertices. So number of vertices means number of edges. Number of edges you have to read, and that value you have to store in the n value. That value you have to store in the n value. So this is my polygon A, B, C, D. So this is the polygon that I have put in the coordinates. So n not less than 3. Whenever you are entering, so what is the definition of the polygon? That must having a number of edges 3. If the user having a freedom, they can enter any point. Suppose the user enter 2 value, 1 value, 0 value. So for the 2 edges you cannot going to draw the polygon. From the 1 you cannot draw the polygon. So it's must having a 3. If that is not less than the 3, so that you have to put the error. Read all coordinate. So how can I read the all coordinates? Suppose I am using a array. So that array you have to start with two-dimensional array. Suppose any declaration of the array. So I can declare the array. Suppose the array I am going to declare over here. So int p of, okay, in square bracket, int p of square bracket. So we have considered first 10, okay, and then over here, so that I have considered here 2. So how can store the coordinates then? That p of, because of array you have to start from 0 0. So p of 0 0 contain your x1, and p of 0 1 contain y1. Now see, so that I'm going to store. This is my integer declaration. This is the array. This is the array declaration. Array declaration. Okay. int, I am going to consider integer. P of 10 2. How I am going to consider it 10 2? Because of 10 is the number of vertices n, and 2 is going to differentiate x value and the y value. See here, that whenever the 0 0 and 0 1, so 0 0 indicate your x1 value and 0 1 indicate y1 value. Similar way, again I am going to store p of 1 0. Next point is going to come 1 0 x2. Correct. Now p of, again I have to consider 1 1. So what is this 1 1 indicate? Your y2 value. Now proceed for the next. P3 means what your next point? P2. P2 0 is your which coordinates? X3. And P what? 2 0 is indicate with what? Your y3. So this is the way that the all values are stored. You have understood the two-dimensional array? In a two-dimensional array, so these all indicate 0, 1, 2, 3 is the number of vertices. So that is going to vary up to the number of vertices. So here only the 3 parameters. So that's why I have considered only 0, 1, 2. And array, the index value always start with the 0 and that end with your n value. Okay. Now n is nothing but your number of vertices that you have started. And here 1 1. So here again you need not 2 0. So I have to again should draw so that you can understood. So here we need the 1 value. Okay, 2 1 1 2 1 we need. So how can I store in the program? See, come. So I0 I1. So I have considered here for loop. For I is equal to 0, I less than n, I is equal to I plus 1. You may write here I plus plus. This is my initialization condition increment. Okay, opening curly bracket, see out. Enter the point. Which point? I. Means 0 point, 1 point, 2 point. So what this message goes to the user and user can enter the 0 point. Suppose the 0 point they have started from the A11. So what is the C in PI0, PI1. So I0 store your X value, I1 store your Y value, and then close your for loop. Close your for loop. Again, go for P of I0, correct, is equal to I00 means what? Your this I0 is what? The last point when this loop is terminated. So what is your value of n? N is the 4. Once the value become n 4, 4 is less than 4? No, 4 is not less than 4. So that's going to exit. So P of 40, whatever your value, your 40 is equal to 00. So what is the 00? The first value. Then P of 41 is equal to 01. So what is the value of over here? Again 1. So this last point is indicates to the first point. That I have shown you on our paintbrush. Now once you draw this all point that stored in a two-dimensional array, so you can easily draw by using a line. So for line, I have to again use your for I is equal to 0, I less than n, I plus plus, line P of I0, P of I1. This is my first x0, y0, P of I1, P of I plus 1. So that is become my x1, y1. So this is the way that you can draw a complete polygon. So how this going to possible? Again, I'm going to show you. See, so this is my first, the point, read the n value. Okay. Once you read the n value, then you have to store your int what int p of, suppose I have considered 10, 2 is my array declaration. In this array declaration you have to start with what, p of, first of all your point p of 0 0. Suppose I have considered p of 0 0. So here you have to store which value, x1. Okay, and then again p of 0 1, here you have to store which value, y1. So this 0, this indicate your what, p of I0 is store your x, and p of I1, is store your what, y. So here your value starting from x1 y1, then what is the value of x2 y2, p of again 1 0 is equals to x2, okay. Again p of 1 1 contain what value, y2. Now p of next value become what, p of 2 0. So p of 2 0 is what, the value x3, and p of 2 1 here become p of 2 1, that is the point 2 1 become my y3 value. So this is the way that you can store. Now once you have come out of the loop, because of 3 is not less than 3, so what I have done, this is the last points to the first point, means what, that whatever the value p of our 3 0, okay, p of 3 0 is equals to p of 0 0, and I have already told you that is the p of 0 0 is my first point, and that must be your last point. And then p of 3 1 is equals to what, p of 0 1, this again your last point. So that is my x1 y1 x2 y2 x3 y3, okay, and this is for your x dash y dash. I am comment over here x dash x1 dash, okay, and this is my y1 dash y1 dash. So here that indicate your point, how this is going to vary, so that you can put in the program. Okay, everybody understood this? Now come for the your point. So this is the way that you can read all the coordinates and draw the any type of polygon. Suppose you are having a convex polygon, concave polygon, so that don't bother. Only you have to read the condition that the number of vertices must be less than that not be less than 3. So that is greater than or equals to 3. Minimum triangle is your polygon. Now, what is our next point, that you have to test whether the point is inside the polygon or outside the polygon. So for testing this, they are having two methods. There are the two methods. What is this method? First method is what, even odd method, and second is winding number method. I mean, suppose I have considered this one polygon and that the one point, and that I have to check by using a programming way. You have to think in the programming way by saying that just I am watching this, so I can easily say this point sir is inside, so why am I going to check it? No, but that program how can know? So for you have to enter the polygon and enter the point any. So program should be answer. Program should be answer. Yes, this is the point inside the polygon and this is the point outside the polygon. So for checking, so what is this even odd method? So that name indicates that you have to generate the even or odd numbers. Now, see, suppose this is my point that are inside the polygon. Now, how you can check it? Suppose one times intersect. Suppose I am going to draw the line, any line that is passing from this polygon, and that intersect. That line intersect 1, 3, 5, 7 means that is all odd numbers. So what that is the all odd numbers indication that is inside the polygon. see how this is going to perform. That's I am going to put again a new screen. Okay. So this is my one of the polygon. Okay. And this is the one I have considered what any point. This is my point. This is the inside the polygon point. Now suppose I am going to draw any line. Okay, suppose I am going to draw any line from this point. So this line exactly parallel. Okay, so this line is exactly parallel to the x-axis because of I have to increment only x value. So what are the coordinates over here for this point? So P point having x and y value. So I have to increase here which point x value. So suppose I am incrementing the x value up to 640. I have to increase up to 640 to draw the line. So that I have to increase this line, means that line going to increase. Okay, so this is the increment you can perform, and this is going to intersect. See here this line is intersecting, that I put in the red line. So that's intersect one time. Okay, so that is inside the polygon. So I'm going to draw another one polygon. See, and that with the color, suppose again consider as I'm black. So this is my polygon, and suppose this is my any point. Okay, now I have to check whether this point, suppose this is my point, is inside the polygon or outside the polygon. So that I have to stretch the point from this point to this one. See the number of intersection of this point. So number of intersection with 1, 2, 3. So 3 is your odd number. So that point is inside the polygon. So whatever the point I have considered over here, that is inside. Now same for outside. How you can consider here? See, this is my outside point, and I am going to draw the line that is intersect 2 times, 4 times, 6 times, so that you can say this point is outside the polygon. Just check. So here again I am going to draw one new figure so that is easy for you. So any polygon I have to consider over here with the black color, and this is the point I have to consider, which is the point. Suppose this is my point, and this point is already outside the polygon, and then I'm going to draw the line. Okay. So I'm going to draw the line that is intersect. So this line is intersect to the polygon. This line is intersects to the polygon 2 times. This first intersection is the second intersection. So 2 is the even value. So 2 is the even value, means this point is outside the polygon. Where you have considered the point here. So suppose I have considered the point P over here. P, that is x, y. Okay, this is the point I have considered, and then I have draw this line. Check for the another one condition so that you can easily understood. So this is the polygon I have to draw with the same. This is my one polygon, correct? Now I have to draw the line. Now suppose the point I have considered any over here. This is the point. Okay. This is the point. So what is the coordinates of this point? Suppose I have considered this point coordinates P, X, Y. This is my point P, X, Y coordinates, and I need to draw the line. Now I can draw the line. See here, by drawing a line, you have to consider like this. Now see how many intersection in this line, how many intersections? That is the 4. 1, 2, 3, 4. And 4 is the even value. So this is the way you can say this the point is outside the polygon. Now the next method is winding number method. In a winding number method, what you can do, so that trace the point in all direction, means x plus, x minus, y plus, y minus. This all line intersect to the edges, means that is your inside polygon. Now suppose I have considered this again, and that is going to intersect to all the polygon. Now see this another figure. This is my inside, so I can check the outside. Suppose this is my point and I am going to draw with the x plus, y plus, x minus, y minus. So only this much line x minus is going to intersect to this edge of the polygon. The remaining is not. So what you can say, this point is outside the polygon. Similar way, suppose this is my point that I have traced x plus, x minus, y plus, y minus, and only x minus, whatever the x minus value, that is not intersecting, but remaining 3 are intersecting to the polygon. Means what you can say, this is my outside the polygon, this point is outside the polygon. So only way, suppose any point that you are tracing with all 4 direction, means x plus, x minus, y plus, y minus, and that should be intersect to the polygon edges. So that time you can say this is the complete inside, this point is inside the polygon. If it is not intersecting any single line, so that you can say this is the outside the polygon. So hence we are going to conclude this today's lecture. In today's lecture, what we have covered, what is the mean by polygon? Any closed figure that having minimum number of 3 edges, that is a polygon. Then you have covered is what are the types of the polygon? Concave polygon, convex polygon. How you can say this is a concave polygon? Suppose you are going to consider any point, or say any 2 points, and then draw the complete line. This complete line inside the polygon, that is called as the convex polygon. And suppose concave polygon is what? Suppose you are considering any 2 points that are inside the polygon and draw a complete line, but that some part of the line is outside the polygon, that you can say is what? This is the concave polygon. Now how can read the polygon? So for reading the polygon, you have to start the starting point, suppose the P1, P0, and you have to enter by using 2-dimensional array. Store all the points P00, 01, okay, that is the 00, 10, 01. So that's indicate your x value, y value. Same way you have to go 1011, 2021, 3031. So this is the way you can read. And then you have to check the inside test and outside test of the polygon. Now that I'm going to complete today's lecture. Thank you.